Welcome to the deep dive. This is where we take the densest industrial documentation, the really deep technical specs, and we distill them down. We find the critical insights you need to get an operational advantage. Our goal is to give you that shortcut to make you the most informed person in the room. Today we're focusing on something that seems small, a really tiny, often overlooked decision that has, well, massive implications for heavy machinery, for its longevity, its profitability. We're doing a deep dive into the operational specifications of a high-performance lubricant, Lubriplate NO 130AA. And our source material, it's aimed right at procurement managers and operations leaders, the people who absolutely have to know how to maximize equipment uptime.
Exactly. And our mission today is to move beyond, just the chemical composition and really get to the financial implications. So when you specify a specialty material, even something as granular as industrial grease, how does that choice translate into measurable KPIs?
Key performance indicators.
Right. We're talking reduced technician hours, fewer unplanned outages, better cost control. We're looking for operational leverage.
And the documentation, it makes a really bold promise right up front. It basically says this compound is built for survival. It's designed to withstand relentless salt spray, aggressive washdowns, deep mud. I mean, the kind of mechanical stress that just destroys cheaper general purpose products almost instantly. The question is, does the performance justify the specialization?
That's the core question.
Yeah.
Exactly. When you see a product engineered to this level, you immediately have to look at the environments where failure is just.
Yeah.
It's non-negotiable.
Okay, so let's unpack this. What are the specific battlefields where operators are pulling their hair out because, their generic grease just can't hold up?
The source material is very, very specific about this.
Yeah.
It's all about where 130 RA is superior because of its resilience to water and corrosives. So think about environments where maintenance is difficult and failure is just incredibly expensive. We're talking about offshore platforms. The constant assault of salt spray and moisture, that's part of the job out there. Then you have utility substations. All that massive gear, it's just exposed to relentless year-round weather. The documentation also specifically calls out rail yards.
Rail yards, okay.
And particularly the crucial turnout mechanisms.
Wait, hold on. For listeners who might not be familiar with rail operations, what exactly is a turnout mechanism?
Well, that's a good question.
Yeah.
It's essentially the moving component of a railway switch. It's what lets a train move from one track over to another.
So if those seize up?
It's a huge problem. If they seize up from corrosion or grit or ice, you have massive delays and huge safety risks. They need consistent, reliable lubrication, regardless of rain or grit. We also see it specified heavily in mining rigs, which, they operate in the most abrasive, moisture-laden, high-heat environments imaginable.
The absolute worst conditions.
The worst. And on heavy-duty manufacturing lines where chemical washdowns are just standard practice, the documentation basically defines these as the places where general-purpose grease simply washes out or breaks down.
That is a brutal roster of operating conditions, which I guess leads us to the key physical characteristic. The documentation, it describes it as tough, clingy, stay-in-place armor for metal contact points. So what's the basis for that armor analogy?
It all comes down to its water-repellent nature. It's formulated as a heavy-duty compound designed specifically to adhere, to really cling to metal surfaces and provide an enduring physical barrier. See, most generic greases are vulnerable to water. They emulsify, they lose their structure, and they let moisture right onto the metal.
And that's when the corrosion clock starts ticking.
Instantly. This compound is engineered to resist that emulsification completely.
Okay, so if it's really acting as armor, we need to know what specific protections it offers. The whole ROI argument, it rests on 4 core claims of performance. Let's break down those 4 mechanical functions that are supposed to deliver that return on investment.
Absolutely. And these are the 4 levers that operators can pull to fundamentally reduce their total cost of ownership. So number 1 is water repellency and corrosion prevention.
The big one.
The big one. They use a very memorable quote saying it repels water like an ex-Marine.
Ah, I like that.
And this isn't just about resisting, a little bit of rain. It's about surviving a high-pressure washdown in a food processing plant or a continuous submersion on a deep-sea cable winch. Preventing that washout means the crucial anti-friction film stays where it's supposed to. It prevents immediate failure and, maybe more importantly, it stops long-term rust on things like pins, bearings, and wire rope.
So it's not a temporary shield, it's more of an integrated, lasting defense.
Precisely. Now, function number 2 is pretty straightforward: wear reduction. Every lubricant does this, sure, but 130 ADA is designed for high shock loads and extreme pressure. It cuts the friction that the source material says eats through shafts, sprockets, and seals. Extending component life, even a little bit, translates to enormous savings.
That makes perfect sense. Now, what about function number 3, adherence under pressure? This feels like the hidden killer when you use a cheaper grease, right?
It is a huge one. And this function addresses two major failure modes. First, you have slinging.
Slinging.
Yeah, in high-speed applications, centrifugal force literally flings off poor quality grease. It makes a huge mess and, of course, leaves the component unprotected.
Okay. And the second failure mode?
That's pump out. This is where the grease actually leaks out of the seal area of a bearing because of high internal heat and pressure.
So pump out literally means the lubricant is being forced out of where it needs to be.
That's exactly right. A high-quality lubricant like this uses a specific thickener system that gives it a higher dropping point, better mechanical stability. It resists being liquefied by heat and extruded past the seals. And think about it. If you use a cheap grease that slings or pumps out, you don't just lose lubrication. You have massive cleanup and compliance costs. You've got fugitive emissions everywhere.
That is a critical point for any manager focused on safety and just general housekeeping. The labor cost of cleaning up flung or leaked lubricant, that can easily outweigh any savings from buying a cheap pail of grease.
Absolutely.
Yeah.
And when you combine those three benefits, you get to the fourth function, extended maintenance intervals. This is the direct operational payoff. Because the compound adheres, resists water, and maintains its film, it significantly reduces how often you need to relubricate.
Fewer relube cycles. That means less labor, less risk exposure for the techs, and fewer production stops.
And that's where the procurement argument really hits home.
Exactly. How do we translate this durability into hard numbers? We're talking about switching your spending from reactive emergency repairs to predictable plan operational efficiency.
That's the core of smart asset management. The documentation really emphasizes that procurement leaders, they're buying predictable equipment life, not just a bucket of material. So let's quantify those impacts for the balance sheet. First, you get dramatic savings from fewer component replacements. Your pins, your sprockets, bearings, wire rope, they simply last longer because they're continuously protected. Second, and this is often more impactful, is less labor. Stretching your preventative maintenance, your PM intervals, by even a small percentage can drastically reduce technician hours, especially overtime.
And the leverage point here is stunning. The documentation suggests that if you run the numbers, stretching those maintenance intervals by even 20 to 30%, that scales into significant fleet-wide savings. How does that ROI math really break down in practice?
Well, when you calculate that gain, that 20 or 30%, you have to look at the total cost of the intervention. It's not just the cost of a new bearing.
Of course.
If a bearing fails, you have the component cost, sure, but then you have the labor cost of tear down and replacement, the overhead, and the enormous cost of downtime, which can be tens of thousands of dollars an hour in heavy manufacturing. So by extending that PM cycle, you're cutting down on all those inputs at the same time. You reduce the number of high-cost emergency repairs, which are unpredictable, and just wreck budgets. And because you're documenting this reduction, you get better compliance. You can show you're actively reducing audit risk and enhancing safety.
And we have a couple of real results anecdotes that take this from theory to, well, absolute practice. Can you tell us about the petrochemical plant example?
Yeah, this one's powerful. A mid-sized petrochemical plant. They were having unacceptable failure rates on their critical hoist chains and cables. They're exposed to washdowns, harsh chemicals.
A tough environment.
A very tough environment. They switched to 130A. And in 12 months, they cut unplanned chain replacements by more than half.
More than half.
Think about that. Having catastrophic failures on critical lifting gear, that is a huge shift from reactive chaos to just stability. And the other validation comes from that rail yard we mentioned earlier. By standardizing on this compound for their turnout mechanisms, they saw corrosion and lubrication bleed-through problems drop materially during the wet season.
So it proves the core strength.
Directly. It proves the water repellency directly addresses those seasonal headaches that typically sideline equipment.
That's compelling evidence. Now, performance is only one side of the coin. For operations leaders, the other side is implementation and risk mitigation. So how do organizations specify and deploy this grease correctly across a complex organization to make sure they actually capture these savings?
Deployment has to be disciplined. The documentation stresses that even the most high-performance grease will fail if the program around it is sloppy. They outline 4 essential steps for a disciplined lubrication program. First, you have to identify your high wear points. Your chains, wire rope, bearings, pins. You don't need this high-spec product on everything, but the critical points absolutely do. Second, you need to choose. Choose packaging that matches the use frequency. You want small tubes for your field service techs doing quick, decentralized PMs, and you want large pails for the central storeroom that's supplying high-volume equipment.
That's just smart procurement strategy, matching the container size to the workflow. You don't want a field tech lugging a 35-pound pail, and you don't want the plant manager stocking dozens of tiny tubes.
Precisely. Third, you follow the manufacturer's installation and lubrication intervals. The documentation explicitly says that the distributor, PE Energy, provides access to all the manuals needed to establish these cycles. This ensures the investment pays off. And here's a crucial training point they make. Techs have to be trained on correct application. The advice is excellent. Less is often more if the grease adheres correctly. Overpacking can cause seal failure.
So putting too much on is actually a bad thing.
It can be a very bad thing. Overpacking generates heat and can actually push out the seal, causing the very failure you were trying to prevent. The discipline is just as important as the compound.
Let's talk about that procurement chain, because that's where you manage compliance risk. Sourcing a high-spec product like this needs to be robust.
Absolutely. The advantage of sourcing through a verified distributor like PE Energy, it goes beyond just competitive pricing. It gives you access to the full suite of supporting documentation. We're talking safety data sheets, technical performance reports, and the OEM manuals you need to validate compatibility.
And that's critical for any kind of audit compliance.
It's essential. If you're running an ISO 9001 program or responding to a safety inspection, you need a verifiable chain of evidence showing you went from the equipment spec to the right lubricant selection. The distributor helps set up, quote, blanket orders. They streamline the whole process and lock in that documentation.
So what does this all mean for you, the listener? We started this deep dive looking at some very technical specifications, and we ended up talking about the company balance sheet.
I think we learned not just what this specialized grease does, repels water, adheres under heat, cuts wear, but why it all matters. It leads to a 20 to 30% extension of your planned maintenance cycles. It can have catastrophic component failures in harsh environments. We've turned technical data into quantifiable operational wins, wins that stabilize spending and improve safety.
And this deep dive really illustrates that good asset management isn't just about cutting costs. It's about investing strategically. Spending a little bit more on a high-specification material like 130AA fundamentally shifts your budget. You move away from those high-cost, unpredictable, reactive emergency repairs, and you move toward predictable, planned operational efficiency. That's the true strategic value here.
And that emphasis on a disciplined program and all the required documentation, the OEM manuals, the SDS, the compliance trail, it raises a really important question for every operations leader out there. If component life and labor savings are so easily quantifiable when you follow a specific program, what undocumented or casual lubrication practices in your own operation might be generating hidden liabilities or unnecessary risk? It suggests that the systemic discipline you implement is often just as critical as the high-performance compound itself. Think about that the next time you look at a maintenance report.